All right, this was recorded in front of a live classroom. Let's make some noise. Yes, all right. Never had this much enthusiasm before. Actually, people were smiling. This is weird. All right, cadets. So we are going to get into a new chapter here, chapter 5. It's all about quadratic functions. So anyway, we skipped section 5.1 because 5.1 was much of what we did last unit in the transformations unit. So we're going to jump into 5.2. 5.2, here's our goals. So you can see that there. We're going to graph quadratics in standard form. So we kind of did that last unit as well. And then we're going to talk about things like the vertex again, and then a new concept, axis of symmetry, and then not so new of concept of y-intercept. So let's get rolling. Uh-oh. There we go. So this is what we did last unit. So hopefully you can look at these equations that are just put right in vertex form and just rattle off the vertex. So I'll give you 5 seconds to look at that, and then hopefully someone can go ahead and give us the vertex here. And all of a sudden everything's weird on this thing. All right, we'll go maroon for Raider Nation. All right, what's the vertex of equation number 1 here? X minus 2 squared plus 3. Positive 2, positive 3, right? So inside is the opposite and outside the same. Good. If we roll down to number 2, vertex on that one should be -1, -4. Agree? Yes, sensei. Good. Yes, sensei. Probably going to get some haters now online because I'm not a real sensei. Alrighty then, still in vertex form, let's talk about this axis of symmetry. So what is an axis of symmetry? An axis of symmetry is an imaginary line, it's an imaginary vertical line that goes through the vertex, which essentially cuts the parabola into 2 equal parts, right? Because parabolas are symmetrical, and they're symmetrical through a vertical line through its vertex. So if you want to find the axis of symmetry, which is just a vertical line, the equation of a vertical line, the equation of a vertical line is this x equals h for this generic parabola with a vertex of hk. So whatever the x value is of your vertex, that is going to be the equation of your axis of symmetry. So if we pop over to the next page, you'll see some examples of this. Here's a couple equations in vertex form. The vertex in this case, if I just draw a little picture on this one, goes through the point. Do a neat color like this one. This will be really good. -5, -8. So we go over here, 1, 2, 3, 4, 5 on the negative, and 1, 2, 3, 4, 5, 6, 7, 8 down there. My vertex is like right there. Okay. So the parabola has a axis of symmetry that is a vertical line through that x value, -5, right? So my parabola has a vertex that is down here, and it goes through that point and is divided by that axis of symmetry. So we would call that axis of symmetry the vertical line x equals -5. That's this gray vertical line there. That's what we call the axis of symmetry. We might start abbreviating that too. How could we abbreviate axis of symmetry? Do a little AOS there. AOS. All right, what's the AOS On the, oh, be very precise. AOS on number 4. I'll draw it all cool like that. AOS is x equals positive 3. Good. So a vertical line going through x equals 3 is where your vertex lies, somewhere on that vertical line. And if you could look at this and go, oh, I know that exactly because the vertex on this one is 3, 1. Okay. Any questions? All right. So sometimes it's not in vertex form, sometimes it's in standard form. And standard form is when we have an equation that is written like this right here. F of x is equal to, and then it's all solved for like ax squared plus bx plus c. So it's written just like a standard polynomial with your highest degree term down to your linear term down to your constant term. So the number in front of x squared is a, the number in front of x is b, the number in front of c is, well, c. That's the constant. All right, and some things are true when we talk about equations in standard form. If the a is positive, it's going to open upward like a little happy face. If a is negative, that's the number in front of x squared, then it opens downward. It's going to be like a sad face, which actually in like 2 slides, if I pop over 2 slides, you'll see. Helpful hint. Dave, you want to read this helpful hint?
When A is
Hold on. Let me get over here, Dave. Right. We'll get Dave on this one. All right, go ahead.
When A is positive, the parabola is happy. When the A is negative, the parabola is sad.
Very nice. I definitely picked the right guy. Well done, Dave. So yeah, happy when A is positive, sad when A is negative. Okay, back to the what we were doing here. The vertex, we already kind of talked about this, and I think this kind of confuses some people when it's written this way. But the axis of symmetry is a vertical line that goes through the vertex, and if it's in standard form, it's always opposite of B over 2A, which might ring some bells for some of you guys that have had some experience with the quadratic formula, right? Some of you guys maybe have worked with that. The old x equals negative b plus or minus the squared root of b squared minus 4c all over 2a, that whole thing. So that is connected to that, and we'll see that later in the chapter. And so because that's the axis of symmetry, then that's also the x value of your vertex. And then if you want to find the y value of your vertex, then you just evaluate f of negative b of 2a, and that is essentially your y value. So you have your x value of your vertex, you have your y value of your vertex. Your y value is evaluated when you plug x in. The last thing is the y-intercept, and we should know at the y-intercept, we know what about x? We know x equals what? Nope. At the y-intercept, x equals. If I look and I go and I go on this y-axis, if I go over to this picture here and I go, all right, I'm on this y-axis. What do I know for sure if I'm a point on that axis? X equals 0, yeah. So that means when I put 0 in for x, I get my y-intercept. And if I put 0 in for x in this standard equation, it's 0, a times 0 is 0, b times 0 is 0, and so the value for the y-intercept is always the constant term c every single time. Okay. So here's some examples in standard form. Let's take 2x squared plus 8x plus 1, and let's find the axis of symmetry. So on this one, the axis of symmetry is going to be the opposite of b over 2 times a, where my a is going to be 2, my b is 8, and my c is 1. So the opposite of positive 8 is negative 8 over 2 times 2, which is going to be negative 8 over 4. So that's going to be x equals negative 2 is my axis of symmetry. So what that tells us is our axis of symmetry, that essentially tells us my x value of my vertex as well. So once I find my axis of symmetry, the x value of your vertex is the same thing. So now all we have to do to find the y value is take negative 2 and evaluate the function when x is negative 2, and that will give us our y value of our vertex. So put negative 2 in for x, and what do we get for f of x or y? So that's 2 times negative 2 squared plus 8 times negative 2 plus 1. Yeah, I didn't write squared. There we go. So that's going to be square it first, you get 4 times 2, you get 8. So that stuff is going to be 8 plus a negative 16 plus a 1. That's going to give me a total of a negative 7, I believe. All in favor say moo.
Moo.
Any opposed? Any opposed say meh. That's what I thought. Okay, y-intercept. I keep doing that. Hopefully I don't swear onto this. So y-intercept is going to be, when I put 0 in for x, the constant term is going to be, I believe, 1, correct? If I go back up without moving the whole thing. Yep, my constant term was 1. All right, good. Any questions there? All right. Oh, we talked about the helpful hint already. Thanks to Dave. Let's consider a function now. It's also in standard form. Let's talk about everything that we have learned so far. So this would be opens up, opens down, axis of symmetry, vertex, y-intercept, and then we'll sketch a little graph. So we'll put it all together. So is this going to open up or down based on the a value? The a value is 2, the b value is negative 4, the c value is positive 5. So since the a is positive, since the a is greater than 0 and it's positive, it's going to open upward. I heard a rumbling back there, yeah? What if a is 0? That'd be funny. It would be a line then. It would be like a line with a slope, possibly. You know, if you had a as 0, then this term would be gone, right? And then the function would just be negative 4x plus 5, which is a line that goes through 0, 5 with a slope of negative 4, 1. Yeah, so it's linear. It's not a quadratic anymore. Okay, the axis of symmetry now is going to be opposite of b over 2a. So I take my opposite of b over 2a, and in this case, that's going to give me opposite of a negative 4 is a positive 4 over 2 times 2, which is 4, which is going to be x equal to 1. That also doubles as your x value of your vertex. So 1 is the x value of vertex. To find the y value, you put 1 into the function for x. So take 1, drive it all the way up here, park it in there, park it in there, and evaluate. So that would be 2 times 1 squared minus 4 times 1 plus 5. What do you get? Well, 1 squared is 1 times 2, so that's 2 minus 4 times 1 is 4 plus 5. 2 minus 4 is negative 2, plus 5 is 3, I believe. Is that what you said? All right, so we got 3. The y-intercept is going to be 0, 5. And so now we can take all that stuff and put it on a graph and put it all together. Okay, the axis of symmetry is at x equals 1, so that's going to go right through here. My vertex is on that line. We determined that it is on that line at 1, 3. So that is going to be up here. And now if I find one other point, I can take that, plot it, and then reflect it. So 0, 5 is my y-intercept. That's going to be right here. And I know since it's symmetrical, it's going to be the exact same y value on the other side of the axis of symmetry. And we said that this was happy, right? So it's going to open upwards, which is a vertex is a minimum. That's a pretty darn good looking parabola there myself. How's it going? You find any split ends? Any questions? Okay, I think we have one more, right? Not bad, 16 minutes, 38 seconds. Opens up or down? Happy or sad? This one is down because it's a negativo, so we'll use the diarrhea color. See, A is negative 1, so it's a sad one. It's going to open down. It's a sad color. The axis of symmetry is going to be opposite of B over 2A. Okay, my B is negative 2, my C is 3, so let's see, my A is negative 1. That's going to be opposite of negative 2 is positive 2 over 2 times negative 1, right? So that's going to be x equals negative 1. The axis of symmetry also tells me my x value of my vertex. And to find the y value now, you just have to plug negative 1 into the function. So let's put negative 1 in there. We have negative, this kind of goofs people up a lot. There's a negative in front of x squared. That's applied after you square it. So that's a negative 1 squared. Okay. Minus 2 times negative 1 plus 3. So you have to square the negative 1. You're going to get positive 1. And then you make it negative. So ultimately this ends up being a negative 1. Minus 2 times negative 1, that's going to be a plus 2 plus 3. So what do we end up with here? 4? Okay, y-intercept is going to be the constant term 3, so that's going to be 0, 3. Let's sketch a graph. X equals negative 1, that's my axis of symmetry. Whoop. Okay, where on that line is my vertex located? Negative 1, 4. It's going to be up here. Okay. My y-intercept is at 0, 3, so that's going to be right there. So that means that point is also going to be located on the other side of the axis of symmetry. And then we make a little sketch of this, and it's going to be an upside down parabola. We'll just make a sketch. We got a few points like that. What do you think? Follow all that? Oh, we're not done yet. Oh, I thought we were done. Shoot. One more page. just for just as a note to all you old school, maybe parents listening out there, the kids nowadays are like, this lesson is like 20 minutes long. So you got to keep it short, otherwise you lose them, right? I guess. Two forms we talked about, vertex form or standard form. Number 7, what do you think number 7 is, in vertex or standard form? It actually could go both. This one's kind of a weird one. So if I rewrote this a different way and I said, and I go, all right, g of x is equal to x minus 0 squared plus 4, you'd say, oh, vertex for sure, right? If I wrote it a little different way like this and I said, oh, g of x is equal to x squared plus 0x plus 4, you'd probably go, oh, yeah, that's standard form for sure, right? So it's kind of like a tweener. It's kind of, you could do either one almost. It's like, well, I don't know, it could be vertex or standard form. Either way, what is the x value of the vertex going to be? 0. So if you did opposite of b over 2a, you'd have 0 over 2. Or if you just did vertex form up here and you're like, oh, okay, 0, 4. Either way, you'd find that your axis of symmetry for that number 7 is 0. All right. Number 8, this one is clearly in standard form. And when it's in standard form, we do the opposite of b over 2a. So in this case, the opposite of b is going to be 2, and 2a is 2 times 5, so that's going to be 2/10 or 1/5. So that is x equals 1/5 is my axis of symmetry. And then just a reminder, when it's in vertex form, you don't need to do the opposite of b over 2a because it's not in standard form. So if it's in vertex form, you can just say, oh, if it's in vertex form, I know the vertex, that's going to be 3, 0. So my axis of symmetry is going to be x equals whatever the x value of the vertex is, in this case 3. Yay? All right. So I think that's a wrap. Here's your assignment. For the assignment, you'll want to do all the stuff we did in class. So the upward, downward, axis of symmetry, vertex, y-intercept, and graph. All right, signing off for now. Hasta la vista.